The QT interval is from the beginning of the QRS complex to the end of the T wave. So from the beginning of the QRS complex to the end of the T wave is the QT interval. Now the next element is the ST segment. The ST segment is from the end of the QRS complex to the beginning of the T wave, and that beginning of the ST segment, which is the end of the QRS complex, is actually represented as the G point, and it is from the G point that you visualize ST segment elevation or depression, as you're going to see in the ECG short video textbook on ECG interpretation. So here is your ST segment. From here to here, ST segment. Now, so those are the different elements that you have to visualize on ECG. Now, the PR interval corresponds to the delay in the atrioventricular node. Is it clear? That PR interval corresponds to a delay in the atrioventricular node. Now, this ST segment corresponds to a delay between the ventricular depolarization and ventricular repolarization. Is it clear? That is that delay in between ventricular depolarization and repolarization. Normally, there should be a delay, but when it is inferior or when it is depressed or elevated, it means that there is an abnormality. Is it clear? So those are the different elements on a normal ECG that you have to understand. Similarly, when you want to interpret an ECG, you have the next point that is going to be the big squares and the small squares. So this is one big square, this is another big square, and this is another big square on an ECG. Now, the big square is made up of 5 vertical lines, 1, 2, 3, 4, and 5, and 5 horizontal lines, 1, 2, 3, 4, and 5. Is it clear? So those are the different things that you have to note on the big square. Now, the big square corresponds to a 5 millimeter. Is it clear? Both horizontally and vertically correspond to 5 millimeter. Now you need to know that what the ECG speed is equal to 25 millimeter per second, meaning that this ECG strip is going to be produced at 25 millimeter per second. So it means that 1 second corresponds to 25 millimeters. Is it clear? So if 25 millimeters, correspond to 1 second, therefore 5 millimeters correspond to x seconds. So you are supposed to find out now the number of seconds now that you are going to visualize. Now this number of seconds, you have to know that it's going to be actually 5 divided by 25 millimeters, and that gives 1 all over 5. And 1 all over 5 corresponds to 0. So those are the different aspects that you're going to visualize. Correspond to 0.2 seconds. Is it clear? So simple mathematics states that to convert from 1 over 5 to 0.2 seconds, you can just say that it is 2 divided by 10. It's actually 0.2 seconds. Is it clear? So mathematics, I'm sure many people have forgotten. Okay, now the next point after that is you have to know that the horizontal plane, that is in seconds, is going to be, for the big square, it's going to correspond to 0.2 seconds. Is it clear? But now you need to know that in the vertical plane, just cram it as to be half millivolts. Is it clear? And that half millivolts correspond to 0.5 millivolts. So everything that is vertical correspond to the big square on the vertical plane correspond to 0.5 millivolts. Now for this small square, we say that the small square is from 5, big square is made up of 5 small squares. Is it clear? So you just say 0.2 in order to visualize the horizontal representation of the small square. It is just 0.2 divided by 5. That corresponds to 0.4 seconds. Is it clear? Similarly, just like 4 divided by 10. if you manipulate it very well. Now, the next element is 0.5 millivolt correspond to a big square. So one small square, which is 5 big, which is 5 small square correspond to one big square. So this is going to correspond, this one small square on the vertical axis correspond to a 0.1 millivolts. Is it clear? So those are the different aspects that you have to visualize. Is it clear? When you are seeing, when you are interpreting an ECG. Now, the next element on ECG interpretation that you have to visualize is that the next element of ECG interpretation that you have to visualize is that you have to know that 30 squares, 30 big squares correspond to 6 seconds. Is it clear? 6 seconds, while 50 big squares correspond to 10 seconds. And actually, this is going to help you in the rule of 6 and the rule of 10 that you are going to visualize later on in the physiologic ECG interpretation. Is it clear? So the rule of 6. So let's start with the rule of 6. So let's start with the 30 seconds correspond to 6 seconds. You have to know that what? You have to know that if one big square corresponds to 0.2 seconds, therefore 30 big square correspond to how many? It is just a simple cross multiplication, x. So if you just do, it's going to be 30 times 0.2 divided by 1. Is it clear? Is it clear? So 30 times 0.2 is going to give you 6 seconds. It tells you just that one. In 30 big squares, you are going to move up for, when you are moving for 30 big squares, you are moving up for 6 seconds. Are you understanding? And similarly, if you just do the same cross multiplication, you understand that 50 big square corresponds to 10 seconds. And now let me just explain from here the rule of 6 and the rule of 10. You need to know that what? In the rule of 6, it is just that you have to take the number of the QRS complexes that you visualize in 30 big squares. In 30 big squares, you multiply times 10. And the reason is, why is it that in the rule of 6 you multiply by 10 and in the rule of 10 you multiply by 6? The simple reason is that in 30 big square you move for 6 seconds. Is it clear? In 30 big square you move for 6 seconds. It means that that is the heart rate in 6 seconds. Is it clear? The heart rate in 6 seconds. So the heart rate in 6 seconds is going to be 30 big squares. It implies that your heart rate in 60 seconds, you must multiply by 10. Are you understanding why in the rule of 6 you multiply now by 10? Because in the rule of 6, that 30 big squares correspond to a movement in 6 seconds. It means that what you're going to have as QRS complex at the heart rate in 6 seconds. So if you want to change now the heart rate in 6 seconds to the heart rate in 6 seconds, that is actually the heart rate, it is going to be a multiplication by 10. Similarly, in the rule of 10, you are moving by 10 seconds, meaning that you are moving by 50 big squares. Are you understanding? And that 50 big squares correspond now to a whole ECG slip. So when you are giving a whole ECG slip, you count all of that is going to correspond to 50 big squares. So now, when you visualize QRS complexes in 50 big squares, it's going to correspond to QRS complexes in 10 seconds. Is it clear? And that is just a heart rate in 10 seconds. So to convert now a heart rate in 10 seconds to a heart rate in 60 seconds, that is actually the heart rate, you multiply now by 6. That is why the rule of 10, you have to multiply by 6, and the rule of 6, you multiply by 10. So those are the different elements of the ECG interpretation, the introduction of ECG interpretation that you have to know. So from henceforth, you are now going to continue with the physiologic elements of ECG interpretation. Thank you.